So in this video here, we're going to be finding factors, and I want to start us off with a basic question. And this question says, is 8 a factor of 104? So I want to start us off with how do we determine if a number is a factor of another number? How do we do that in general? So take a moment to try to figure this out on your own, and then come back and play the rest of the video. Okay, so one way students do this is just to see if that number, the larger number, can be divisible by the smaller number. So does 104 divide by 8 evenly? And if you put this in the calculator, it does. You got 13. So 104 divided by 8 gives you 13, and there's no remainder. And so in this case, you can imply that 8 is a factor of 104 because there are no leftovers or there are no remainders. If it didn't divide so nicely, then that's questionable that it is a factor or not. Like this one here. So we're using the same number 8. We're going to check to see if it's a factor of 110. So let's try this. 110 divided by 8. And if I put this in my calculator, I get 13.75. I get a decimal number. So I see that it's not dividing so nicely. It divided about 13, but then there was some left over. And so I have a remainder with this. So I can see 8 is not a factor because I have a remainder. Okay, so now you're probably thinking, okay, what's the point of doing this? Well, there's actually a really significant point to how this connects with synthetic division. So turns out, like when you have expressions, it's hard to know if something is a factor or not. But one way we can figure this out is to check if there's a remainder or not a remainder. If there is one, then we know that it didn't factor nicely. If there's not a remainder, then we know it is a factor because it divided evenly. So let's apply this to example 4 here. So in this problem, we're trying to factor the expression. So here's the expression, but we can do this using synthetic division. So what we're going to try to do is I've picked out a factor, and I want to see if it's a factor of this polynomial here. And the way I can do it is using synthetic. So basically, I'm trying to see if I divide this into this polynomial, do I get a remainder or do I not? If I get a remainder, then I know this can't be a factor. If I don't get a remainder, then I know that this is a factor because it divided in evenly. All right, so let's get started. So if I want to divide this into this, that means I need to find the 0 of x, so that way I can put that number in my box. Well, this is x minus 3, and so you can set this equal to 0 and then solve for x, so you would add 3 over, and x is equal to positive 3. Or basically, take your factors, switch the signs, and there you have your number that goes in the box. So from here, I have my highest power is x to the third, so I'm going to write out all my terms from highest to lowest power. And then it looks like my coefficients that are in front of it is a 1, a 4, a negative 15, and a negative 18. So I'm taking the coefficients in front, and I'm putting it underneath each term. From here, if you watched the previous video, you pull down the first number, and the numbers down below the line, you always multiply it with the number in the box. So 1 times 3 makes it a positive 3, and then you always add vertically. So 4 plus 3, 7. 7 times 3 is 21. Negative 15 plus 21 gives me 6. 6 times 3 is positive 18. And if I add vertically, these actually cancel, so I get 0. So that means I have a remainder of 0. So if this is the remainder, that means that this did divide evenly. So I can say that x minus 3 is a factor. But let's see what we have left over. So this is the constant, the x to the first, and x squared. Remember, we always increase afterwards. So remainder is always at the end, then the constant, and then just increase the x power. So it looks like I got my factor to be 1x squared plus 7x plus 6. Okay, so what does this all mean? Well, right now it means that you have x squared plus 7x plus 6 as a factor, and you've also included x minus 3 as a factor. So this here, if I were to multiply it with x minus 3, I would get back to this here. So what I've done is broken this up into two factors now. I can't factor this anymore, but maybe I can factor this a little bit more. Like I notice it's a trinomial, so maybe I can factor it a few more times. So let's write down our x's. What two numbers multiply to give us 6? And you guys would probably think maybe 6 and 1 would work because the middle term here is a 7. So I need to add to make sure I get a 7. Then I'll put my plus signs down because they're all plus signs here. So let's see if this works. X times x, x squared. 6 times 1 is positive 6, but when I add 6 and 1, I get positive 7. And so that will get me that 7x that's in the middle. So let's drop down our x minus 3. So I can't factor these two any further, and neither can I factor this guy. So I am done. I found the factors of this polynomial here. And so this here, maybe I could have done it with grouping and that might have been easier, who knows. But I can definitely say you can use synthetic division to factor as well. So with synthetic division, all you do is take the factor that they give you. This is assuming they give you one already. And then you're going to use synthetic division with it. And so if your remainder is 0, kudos for you. This is definitely a factor, so you can use that as one of the factors. And you're going to see what you have left over after synthetic division and pop that over. And you'll have to factor it if it still needs to be factored a little bit more. And so once you can't factor anymore, those are going to be your factors. So I was able to continue this problem just because my remainder was 0. So let's take a look at another case here. So this one here is pretty much the same problem, only this one has an x plus 3. And these numbers are still the same. So you're going to check if x plus 3 is a factor of this guy. And so same thing as before, you're going to set up your box, find the 0 of this. So if you set this equal to 0, x is going to be equal to negative 3. And then I'm going to set up my term. So x to the third is the highest. So then I'll write the coefficients underneath. So it's a 1, 4, a negative 15, and a negative 18. So I'm going to take the first term, drop it down, and so that will be a 1. And then I multiply it diagonally. So 1 times negative 3 is negative 3. Add it with the vertical numbers. So 4 plus negative 3 ends up being a 1. 1 times negative 3 is a negative 3. And then I'm going to add vertically, and so that makes it a negative 18. And then negative 18 times negative 3 makes it a positive 54. If I add vertically, this definitely doesn't give me 0. It gives me 36. So I can see right now my remainder is not looking so good. So because I actually got a remainder, that means I can't do this problem further because this is not a factor. So because it didn't divide in evenly, and because my remainder is not 0, it didn't divide in evenly. So this is not a factor. And so I would just stop right here. So I can't solve this problem. So I'm just going to stop. So only if your remainder is not 0, you want to pause the problem. You can't solve it out. You'll have to use a different method for solving this equation. So I recommend maybe since there's 4 terms, you can use grouping. And that's basically it for that problem there. So it just wanted us to check if it is a factor. So it's definitely not a factor. Whereas this one in here was a factor, so we could say yes, it is a factor. And this one we actually found the rest of the factors. All right, so let's get into its application. So in example 5, what you're going to be doing is you're also given one of the factors or a potential factor, and you're going to use synthetic division to check if it's a factor. And if it is, you have to factor it out completely. Okay, but if it's not a factor, then stop right there, pause on the problem. All right, let's try out part A here. I'm going to zoom into that. So it looks like I need to check if x plus 1 is a factor. So you can set this equal to 0, find your 0 first. So I would have to subtract over 1, x is going to be equal to negative 1. So I'm going to make my box and put a negative 1 inside. And it looks like my highest power is x to the third. So I'm going to start labeling things out and then putting the coefficients below. So it looks like I have a 1 here and a 1 here. So 1, 1, negative 16, and another negative 16s. So from here, I'm going to carry down the 1 first, and then I'm always multiplying diagonally. So 1 times negative 1 is negative 1 that I add vertically. So 1 minus 1 ends up being 0. 0 times negative 1 is 0. So that ends up being negative 16. And then negative 16 times negative 1 ends up being a positive 16. So when I add these two, they actually end up giving me a 0, so they cancel. And so my remainder is a 0. So that means x plus 1 is a factor. So to the side here, let's write out all the factors that we know. So we know that this here is going to end up being our constant, our x to the first, x to the second. So I can see that my factors are going to be x to the first, or x squared, 1x squared. This here is a 0, so I know I don't have x to the first. And then I have a minus 16 as the constant, so that's a factor. And I know that x plus 1 is going to be a factor because my remainder is 0. So this is a factor, so I'm going to use that. And then from there, what I could do is maybe this is a quadratic, maybe I can factor that some more. So there's a rule of thumb that if this is a perfect square and it's a difference of perfect square, you can factor it, x plus and an x minus. So if we think about 16, two numbers that multiply to give you 16 is 4 times 4. So we can make this 4 and 4. But you want to use a negative and a positive because positive 4 times negative 4 gives us that negative 16. And x times x gives me that x squared that I'm looking for. But whenever you add 4 and negative 16, they cancel. So that's why there's not a middle term. And the x plus 1 just comes down. And so from here, I can't factor that anymore. So these are my 3 factors. All right, so I'm done with that problem. Let's try out one more here, and then I'll let you guys practice some. So with this one here, I have, let's see, x minus 1. So you can set that equal to 0 to find your x value. So if I set this equal to 0, my x would end up being a positive 1. So I'll kind of skip that part. My highest power here is x to the third. And then it looks like my coefficient has a 3 in front of x cubed, a 10 in front of x squared, a negative 1 in front of x, and then a negative 12. All right, so from here, I'm ready to go. I pulled out my first number, and this is a 3. So 3 times my box number, which is 1. 3 times 1 is 3, and then I add vertically. 13 times 1 is 13. If I add vertically, this ends up being a 12. 12 times 1 is positive 12. If I add, I end up getting a 0. So again, I get a remainder of 0 here. So this is my constant, my x, and my x squared. So I know that x minus 1 is a factor, so I'm just going to go ahead and move it over. And then write out what I also have. So I have a 3x squared, a 13x, and a 12. So I know when I take this here, this equation, and I multiply it by x minus 1, I would get back to this polynomial. So these are my 2 factors, but I could probably factor this a little bit more. But this one's tricky because the number in front of x squared is it's not a 1, it's a 3. So a while back ago, you guys might remember if you want to factor with something that doesn't have a 1 in front of x squared, you can use slide and divide. So let's just remind ourselves how to do slide and divide. So you always slide a, or the number in front of x squared, over to c, or the constant. So this is going to be the slide and divide method. So put a little note there. So what that will do is drop the 3. And so what you're doing is sliding it over to 12, or you're multiplying. So 3 times 12 gets you to 36. And then you can factor from there. And so two numbers that multiply to give you 36, but add to give you 13. So there's 9 times 4. There's 6 times 6. But I think 9 times 4 would work because they add to give you 13. So let's try that. So maybe x plus 9 and x plus 4. But remember, you have slided, you have factored, now you need to divide. So I'm going to divide the number that I multiplied with, which was the 3. So I'm going to divide each number by 3. So this ends up being x plus positive 3. And then this 3 does not divide into the 4 evenly, so we're going to put that 3 in front of the x and then drop down the 4. So anytime it doesn't divide nicely, you can put the number in front, and then that number just comes down. Okay, so I now have my factors, and you can double check if it works. So x times 3x gives you 3x squared. 3 times 4 gives you that 12 you're looking for. And if you multiply your inner terms, 3 times 3x gives you 9x. But add it with the x times 4 gives you 4x. If you add it together, you get 13x. And I'm going to bring down the factor that I had before. So x minus 1 just comes down. So these two I can't factor anymore. And this one I just brought down. And this is going to be my final answer. So that one was kind of a long one, but that one's just a good reminder of how to use slide and divide. It comes in handy whenever you have an x squared, but the number in front, your leading coefficient, is not a 1. All right, that is it for this video. If you want to try out some more practice problem, there's a ton down below. I highly recommend practicing some of those synthetic division just to kind of keep up with those skills. All right, until next time, guys. Bye.